So this is the second lesson in the trig unit. It's called the unit circle. As the name says, it is a circle centered at the origin with a radius of 1. Unity 1 and then a circle. Alright, so before we go any further, let's have a look at this. We can find its equation by using any point on the circle and Pythagorean theorem. So if you have something like this, and then right here you have a point with coordinate x and y, and of course this is a unit circle, so therefore the radius here would be 1. And then if you look at the coordinate x and y, so that means it is x unit across. Well, let me just make a triangle here first. So that means the length here, or the width actually, would be x, and the height here would be y. And because it is a right angle triangle, so therefore we can apply the Pythagorean theorem, or Pythagoras, whatever you call. Okay, so that's of course a square plus b square equals to c square. Which side is a, which side is b, doesn't matter. You can call this a and then b, or a and then b. This is c anyway. So if you plug the numbers in, my a is x, my y is b, so that means we would have x squared plus y squared, and then in this case your hypotenuse has a length of 1 unit, so 1 square of course gives you 1. So this is the equation for the unit circle. You can use this to draw something like this. How can we do that? Let's look at the graphing calculator. And before that, we have some extra work to do first, because there's no way we can plot this. So if you manipulate this, we have y squared equals to 1 minus x squared. And then if you take the square root of that, because on your calculator you can only have y but not y squared, so basically this would be 1 minus x squared. So let's plot this. 1 minus x squared, square root of that, so square root of 1 minus x square. Graph. So in this case, as you all know, I always like to use a standard grid, so that means this is 1 unit, negative 1, so 1 unit as a radius. But now where is, it doesn't look the other half, because it doesn't look like a circle. Okay, so because what happens is, when you take the square root of something, remember you need to put down plus and minus. So this is plus, let's do the minus thing. Okay, keep the first one. Now this time I'm going to do exact same thing, except this time I have negative in front. 1 minus x squared, and graph. You should see the second half of the graph. Look at this. Now you have a circle. I know it doesn't look like a circle. Okay, it looks more like an ellipse, but it has something to do with the way they do this. If you look at this, here 1 unit is this y, here 1 unit is that narrow. That's why you look like an ellipse, not a circle. But trust me, it is actually a circle. So if you look at this, before I do an example, you need this. So instead of saying x squared plus y squared equals to 1 squared, this one here is actually the radius. So you can say that x squared plus y squared equals to r squared. This would give you any equation, or an equation that would describe any circle. Okay, x squared plus y squared equals to r squared, except r is 1. Okay, so now let's work out an example. And In this case, your origin is 0, 0, just like this. Origin is 0, 0, except this time your radius is 2. So find the equation for this scenario. Origin is at 0, 0, or a point at 0, 0, and then with a radius of 2. So basically you apply the same thing. X squared plus y squared equals to r squared, and in this case your r is 2, so you plug in 2 here, so you can rewrite that as x squared plus y squared equals to 2 squared, which is 4. Done. Okay, I hope I don't need to spend too much time doing things like this. Now another one, same thing. The origin is the center, and then center of the circle, and you have a radius of 2 root 5. So same idea. So x squared plus y squared equals to r squared. So if you look at this, the only thing we know for sure is the radius, which is 2 root 5. So if you write this, x squared plus y squared equals to r, which is 2 root 5, and then you square the whole thing. So of course we can simplify, or we can we can just simplify this a little bit, so we can rewrite that as x squared plus y squared equals to, so 2 root 5 squared, so that means 2 root 5 times 2 root 5, so 2 squared gives you 4, and then square root of 5 squared gives you 5, 4 times 5 gives you 20. So if you use this formula, of course you have to manipulate that and then plug in whatever you have, y equals whatever, of course plus and minus like this, then you would end up with a circle that has the center at 0, 0 with a radius of 2 root 5. Okay, next, determine all the missing coordinates on the unit circle given here. So in this case, same idea. You have a point 4/5 and y, and because it is a unit circle, keep in mind this is the key term, unit circle. So that means the radius is 1, and we're going to take advantage of the same thing again. X squared plus y squared equals to 1, and then we plug this in, because if you look at this, this is coordinate of the point. We are find this missing coordinate, so that means my x is 4/5 and my y is the missing y. So plug all this in. X is 4/5, so 4/5 square plus y square equals to 1. And of course the rest is just simple algebra. So you can take advantage of your calculator, plug this fraction in to find out what is the value for the square of this. And this one for me is simple enough, so I'll just do it this way. 4/5 square, so 4 square is 16. On the bottom, 5 square gives you 25, plus y square equals to 1. Now when I say 1, I mean 1 square. I hope you all know that. Anyway, a squared plus b squared equals c squared. Anyway, so if you subtract 16/25 on each side, then I have 1 minus 16/25 on the right hand side. And then of course you can simplify this. So y squared is equal to 1 minus 16/25 is 9/25. And then if you take the square root of that, square root, every time you take the square root of something, make sure you put down plus and minus. Sorry, it's a bit messy and tight. So on the left, after taking the square root, you have y. And then right hand side, when you take the square root of 9/25, you have plus and minus. Don't forget, square root of 9 gives you 3. On the bottom, square root of 25 gives you 5. So that means the missing coordinate y is positive 3/5 and negative 3/5. How could that be? Have a look. So the first coordinate would be 4/5, positive 4/5, and then 3/5, like this. So you have a line, oops, wrong color. like this. This is 4/5 and 3/5. And then another one is 4/5 and then negative 3/5. Positive 4/5 and then negative going down. So like this. So 4/5 and then negative 3/5. Alright, so I hope you don't find this too bad. Let's do another one. Okay, x and 5/13. Find the missing value, in this case x. So we are going to do the same thing. We have a circle and just this kind of stuff. So I'm not going to go over this, but at least we know that in order to the equation for this circle is going to be x squared plus y squared equals to r squared. Okay, this is x. X is still x. We don't know that. And then what's my y? 5/13 square equals to, in this case, r is the radius because it is a unit circle. So 1 square if you want. Okay, so let's simplify this further. X squared plus, so 5/13 square gives you square on the top, 5 square gives you 25, square on the bottom, 13 square gives you 169, right hand side 1 square of course is equal to 1, and then simple algebra, subtract 25 over 169 on each side. Again, you can practice in your calculator. So x squared is, so 1 minus 25 over 169, that gives you 144 over 169. And then take the square root on both sides, and don't forget the plus minus thing, plus minus, sorry, I should have left some more space here. So left hand side is still x, well not still, sorry, it's now x. Right hand side, of course, plus and minus. 144, I hope you know that it is a perfect square for 12. So 12, the bottom, 169 is a perfect square of 13. So that means my two x values are 12/13 and negative 12/13. So let's sketch it here. So 12/13 for x and then 5/13 for y, so up like this. So 12/13, 5/13. Okay, another value is negative 12/13, negative 12/13, and then 5/13 up. So negative 12/13, 5/13. So like that. Alright, so let's keep going. We know that theta equals to A over R. That's from last day. If you don't remember that, never mind, right here. We already checked that off. Okay, so, and it works for any circle as well. So we also know that in the unit circle, radius is 1. So you have something like this. Any point here with coordinate x and y. Then we can conclude that theta is the same as A. Because if you look at that, we replace R by 1. So that means A over R, or A over, is now A over 1, which is A. A is equal to angle theta. Right? What's special about that? This means that a central angle and its subtended arc on the unit circle have the same value. So whatever angle you have is the same as the arc length. This angle is the same as this. Now we are going to derive the values on the unit circle with special angles 30, actually 0, 30, 45, 60, and 90. 0 and 90, they should be straightforward, but then for angles 30, 45, 60, they you need to know them. And if you still remember from last year, we talked about the special cases from last year. Remember the 90, 45, 45, 90, 60, 30 thing? Anyway, so we will use that to help us figure things out. I'm not going to work out all of them. You can look at the notes because this deriving part, you would never need to know how to derive these on the diploma exam. Of course, you don't have diploma exam anymore. So now if you look at this, so let's talk about the first special case, which is 90 degrees. So multiples of pi over 2 or 90 degrees. So for this one, 0, 90, 180, 270, 360. Well, this is easy. So if you look at this, what's the coordinate of this point? 1 and 0. And this is for 0 degrees. 0 degrees. And then this one is 90 degrees or pi over 2. Let's stick with this, the radian measurement, because we'll be talking about radian measurements quite often for the rest of this unit. So what's the coordinate here? My bad, maybe I should take out this degree here based on what I just told you. So if you look at this, what is the coordinate here? This is of course 0 and 1. Remember, this is a unit circle. So this is 0 and 1. And this one here is 180 degrees. We can represent that with pi. And then the coordinate of this point, -1 and 0. And then this one, 270 degrees, we can represent that. Well, hope you know how to convert that 270 degrees into pi in radian. So that is 270 degrees, which is same as 3 pi over 2. And this one, the coordinate is 0 and -1. So there's nothing too special in this case here. Let's look at other scenario for the coordinates of a point on the circumference of the unit circle. So let's talk about 60 degrees. So 60 degrees, you can call that pi over 3. I'll write down both. All right. So if you look at this, if this is 60 or pi over 3, I don't care which one you write down. That's a right angle triangle. And of course, we know the length here is 1. So if you recall from last year, Math 20-1, for the special case, 90, 60, 30. If you don't remember this at all, never mind. If you care, then you can look at the notes from Math 20-1 in the trick unit. Okay, if not, I'll just give you the numbers. Okay, so the angle, the length opposite to the angle of 90 degrees has a length of 2, and then the length of the side opposite to the 60-degree angle has a length of 3, root 3, and then the one for 30 degree is 1. You probably still remember there's 2 root 3, 1. So let's fill in the information here. So if you look at this, that means we have a triangle of this. This would 2. And in this case, we are talking about 60 degrees. So for 60 degrees, it would be root 3. And then this side, 30 degrees. So that means the length of this side would be 1. Now, the problem, why you might be wondering, why didn't I write down 2 root 3 and 1 here? Because here, it has a length of 1. This is a unit circle. This looks like this, except that this doesn't have a length of 1. So how can you convert that into 1? Of course, divide this by 2. so that you end up with 1. If you divide this side by 2, you divide all the other sides by 2. So that means on a unit circle, the length here would be 1/2. Maybe I should erase this here. You don't have to erase yours. So that means the length here is 1/2. This is 1, and this is root 3 over 2. Root 3 over 2. Okay? So if you look at this, now what is the coordinate of this point here for 60-degree angle? So this coordinate would be 1/2 and root 3 over 2. 1/2 root 3 over 2. What about this one here? Let's say if you have another 60 degrees. Because these two are symmetrical, so if this one has a coordinate of 1/2 and root 3 over 2, that means this one should have negative 1/2, because this is a negative x value, and root 3 over 2. And if you extend that to quadrant 3, same idea. So what would be the coordinate of this point? If this is negative 1/2, this would also be negative 1/2 as well. If this is root 3 over 2, this would be negative root 3 over 2. Last but not the least, quadrant 4. If this is 1/2 and root 3 over 2, 1/2 root 3 over 2. Then for this one, the coordinate would be 1/2 as well, except for the y value is going to be negative root 3 over 2. Okay, so let's move on to this one, 45 degrees. Or pi over 4, doesn't matter which one you use. So we can construct a triangle in the same manner. This is 45 degrees of pi over 4, doesn't matter which one you write down. Again, that will make a right angle triangle. But before we move on, I just want to label this as 1, and then let's construct our own triangle here. So if this is, well, let me use the 45. If this is 45, that means this is also 45, and hopefully that brings your memory back, because we have 90, 45, 45. So 90, 45, 45. I hope you still remember this from last year. If not, again, never mind. You can look at the notes or just take it and use that. So in this case, same idea, except the numbers are of course different because the angles are different. So the side opposite to 90 degrees has a length of root 2. Root 2. And then the sides opposite to 45 degrees, they have a length of 1. So 1 and 1 here. So by plugging these values in, and again, if you look at this, this has a hypotenuse with a length of 1. This one has root 2, so we need to divide the hypotenuse by itself and then divide all other sides by root 2, because if you take root 2 divided by root 2, that gives you 1, which makes this 1, which complies with the unit circle, that the hypotenuse or on the circle, which is the radius, has a length of 1. Okay, so this is 1, and then the width is 1 over root 2. 1 over root 2, and then the height here is 1 over root 2. So if you look at this, now we have the values. So what does that mean? That means 1 over root 2, 1 over root 2. What's the coordinate of this one? 1 over root 2 and 1 over root 2. And we can quickly derive the others. So we can have this, and we can derive all the other coordinates with the same manner, just like the last one. So I'm not going to go over all those in detail. Instead, I'll just give you the number. So this one would be negative 1 over root 2, and then 1 over root 2. This one would be negative 1 over root 2 and negative 1 over root 2. And this one is 1 over root 2 and negative 1 over root 2.